right, so we're continuing our talk about factoring in chapter 5. So section 5.3, we're just going to look at a couple of special situations that arise when we're factoring so that we can know how to deal with them. And in general, I think that these aren't too bad to have to deal with. Probably, again, knowing that you've seen factoring before at some point, I'm sure you've seen this stuff. So what I want you to do, I'm going to give you 20 or 25 seconds. Exercise 1, multiply these two things together. Just real quick, do a FOIL on that because I'm interested in the structure of the result that we'll see. All right, so we're going to first outers, inners, lasts to this like we did. This is how we started out the last section. So here we go. My firsts, my x times my x is going to give me x squared. My outers, my x times my -9 is -9x. My inners, my 9 times my x is plus 9x. And last but not least, the 9 times the -9 is -81. And when all is said and done, and when I go ahead and I add my like terms, what happens to my outers and my inners on this one? There's no more. They cancel. What about the original problem is significant here that makes my outers and my inners cancel? Yeah, we've got the same two values. We've got an x and a 9, but I've got a positive between one and a negative between the other. That's the significance here. So my outers, my inners, a -9x, a plus 9x, those cancel. I have x squared minus 81. And so I have this thing with two terms. And since factoring is starting with things like this and going backwards, I want to be able to recognize this. And so what this is called is a difference of squares. Now, math people, when they label things, they tend to be descriptive and not creative. And it's called a difference of squares for two reasons. What does the word difference refer to? Okay. It's a subtraction problem. Okay, so I'm just going to draw a little arrow to the subtraction sign. Has to be a subtraction. You're 100% exactly right. And so it's a difference of squares. And the squares refers to the terms. Both terms are perfect squares, meaning they're the same thing times itself. So that tells you what you're looking for to be able to factor. So that takes us to our next exercise right under the heading difference of squares. I want you to circle the expressions below or expression below that are a difference of squares. So again, I'm going to give you 30 seconds. Circle any and all that you think meet the criteria of being a difference of squares. All righty, should I circle the first one? Is the first one a difference of squares? No, why is it not a difference of squares? Okay, it's got a positive. Put a little arrow right there, so that is not a difference. That's probably the most common mistake, is students getting fooled by a sum of squares. You can't do anything with a sum of squares. How about the next one? Should I circle number 2? Yes. 4y squared is 2y times 2y. 25 is 5 times 5. They're both squares. It's a difference. So yes, that's a difference of squares. How about the third one? Is that a difference of squares? Why is it not a difference of squares? Well said, with lots of confidence. I love that. So not a square. So since it's not a square, we can't factor that. There's nothing we can do with that expression. And last but not least, 81 minus x squared. Should I circle that one? Why not? That's why I put this problem on here, is I don't want us to get into the habit that variables always have to come first. Okay, so does it meet the two criteria? Is it a difference of two things? Yes, there's a minus sign between them. That's subtraction. Are both of these things a perfect square? Yes, even though the x squared comes second, and I understand why that hung you up. So again, I was predicting that. That's why I put this problem on here, even though it is a difference of squares. So we could factor that. Okay, so we'll talk about that in just a minute. Okay, so now that we've recognized some difference of squares, and we've seen where difference of squares come from our foiling, the last question remains, okay, what do I do to factor it? Okay, well, here goes. I'm going to take that 4x squared minus 25 that we just saw a moment ago, and we're going to go ahead and we're going to unfoil it. Well, difference of squares, nice and hopefully relaxing. The 4x squared, what times what gives me 4x squared? Yep, 2x and 2x. What times what's going to give you 5? Perfect. And then just as we saw above, there are no outers and inners here. So that means I have to make my signs different. So it doesn't matter the order. Okay, so I'm going to put the plus first and the minus second for no particular reason. Okay, so there we go. 2x plus 5, 2x minus 5, factored. Great. Do exercise 3. I'm going to give you 15 seconds to write down the factored expression for exercise 3 right next door. All right, when I unfoil this one, here we go. X squared, what two things are going to give me x squared? X and x. How about 100? How do I factor that? Yep, we're going to use 10 times 10. We want the perfect squares. I know 25 times 4. I know 2 times 50 would give me 100. But since this is a difference of squares, you're going to use the two things that are the same. And then I'm going to use plus 1 minus the other. Order doesn't matter. Before we go to the next row, I just want to finish up on that other one that was a difference of squares up above. Real quick, factor 81 minus x squared when I put the x second. All right, so I'm hoping everybody would say that 81 is going to give me 9 times 9. X squared again is x times x. And then I'm going to have plus 1 and minus the other, or minus and plus. The order of the signs does not matter at all. If you've got a question, please ask it. We're just going to practice more of these. Yes?
Does it matter if like the x is in front of the 9?
What do you mean the x is one in front of the 9?
Like negative x plus 9.
You can rearrange those terms afterward if you want. That's fine. X plus 9 is the same as this. Negative x plus 9 is the same as that. But I'm lazy. I'm not going to do any more work than I need to. So I'm going to stop right there. Okay, so great question. You can always rearrange the terms of any addition problem. All right, do exercise 4 for me, please. So as I'm writing my parentheses, what times itself gives me 64y squared? 8y and 8y. How about the 1? What times what? Yeah, 1's my favorite. 1 and 1, and then minus 1 plus the other, or plus the minus. The order of those two things don't matter. If you've got a question, ask it. If not, go on and do exercise 5, please. So 81y squared is 9y times 9y. 49x squared is 7x and 7x plus one pair, excuse me, minus the other pair. We doing okay? Okay, that's your straightforward difference of squares. Now I got 2 more problems just to give you little twists to this, because I know I don't want this to be too easy for you. Okay, so the next one, exercise 6, do your best to factor that completely. If you can at least do the first step, that's great. And if you do the second step, that's amazing. All right, so looks like a difference of squares. Let's see if it is. What times itself gives me x to the 4th? Okay, x squared and x squared, great. So far, we so good, everybody good? And then 16 is 4 times 4 plus 1 minus the other. If you did that, you did an amazing job. Okay, so don't beat yourself up. Don't kick yourself if you didn't do the second part. We always factor completely. Okay, so looking at these two things, x squared plus 4 and x squared minus 4, is either of those able to be factored further? Yeah, one of them is a difference of squares, right? So I can go and do this a second time around. So the x squared plus 4, that has a plus between it. So that is not factorable. So that is just going to be part of the answer. I'm just carrying that down. But then this x squared minus 4, I can go through the process again. X squared is going to give me x times x. 4 is going to give me 2 times 2 plus 1 minus the other, or minus and plus. Again, the order does not matter. And now at the end, none of that is able to be factored any further, so I am finally done with the problem. Yes, if the instructions are to factor this completely. So yes, you got to keep going all the way. So great question. There'll be a couple like that on the homework, and I love that problem. So there'll definitely be something like that on the test, that your difference of squares will break down to another difference of squares. So spoilers, I know you hate it when I tell you exactly what's on the test, but you know, I'll just keep doing it. Okay, exercise 7. Exercise 7 doesn't look like a difference of squares right off the bat. What do I need to do with that one first, do you think? Take out the common factor. Yes, there's nothing to group here because there's not 4 terms. Okay, so we only group things that have 4 terms, but I do notice that both terms have a 5. So what I would recommend is take that 5 out first and then look at what's left. Okay, so the question, in case you didn't hear, is why on the previous exercise was I able to factor the x squared minus 4, but the x squared plus 4 stays the same? Did I understand your question correctly? So this goes back to the very top When I end up with something that's factored and I have these different signs here, notice where did that come from? Well, when we multiplied it, so factoring is just going up the ladder. So when I multiplied, I got x squared minus 81. There's a minus sign there. So what that tells me is anything that has a minus, I can then go backwards and separate it into these two factors right here. Okay, pluses you can't. In fact, we will talk about much later in the class. It'll be the very last section. We will talk about what we can do when there's a plus between these two things. But for now, when you see the plus there, that's a roadblock. You can't factor that any further. Okay, did that better? Awesome. Appreciate the question. Always ask your questions. All right, so exercise 7, I'm going to take that 5 out first. That was the very first thing we did in chapter 5 here, taking out a common factor. So I will do that, 5. And so 5a squared, when I factor out the 5, leaves me what? Yep, indeed it does, a squared. And then negative 45b squared, when I factor out the 5, leaves me what? Negative 9b squared. Great job. And so that 5, remember, anytime we take a common factor or anytime like in exercise 6, we have something that can't be factored any further, it's still part of the answer because I should be able to, at the end, I should be able to multiply all this together and get what I started with. And so over here, the 5 comes down as part of the answer. And now a squared is a times a. Negative 9b squared is 3b times 3b. Plus 1 minus the other, or minus and plus. The order does not matter. All right, unless there's any more questions, that's all I have to say about difference of squares. Anybody got anything else that they're unclear of at this point on difference of squares? All right, remember, practice makes perfect, so keep practicing and make sure that you got that in your sleep. So when I put 2 or 3 of those on the test, that you can just go ahead and mop up all those points. The next thing that's kind of part of our special factoring, I don't really consider this too special, although I will show you a shortcut for this, is something called a perfect square trinomial. So remember, the word trinomial means something with 3 terms. So you can see both of these exercises that we're going to do at the bottom have 3 terms. Well, we're just going to treat this like a regular old trinomial, like we did last time. Okay, like I don't want to give you any special methods when they're not needed. So I'm going to go ahead. There's a 1 in front of the squared term. So this is the situation that I'm unfoiling. So my firsts are x squared. So that means it's x times x. I have a plus 36 at the end. So just as review, what does this tell me about my signs? They got to be the same, but yes, those of you who said they're both negative, you're just a step ahead of me, so great job. So they both have to be negative because they're going to add up to a negative 12. And then what 2 factors of 36 add up to 12? 6 and 6. So notice the reason this is called a perfect square trinomial is because you have the same factor times itself. And so one more notational step is required here. When you notice you have the same factor times itself, just take that x minus 6 and then write a little squared up top instead of writing the same factor times itself. And that's why that's called a perfect square trinomial. So I'm going to give you 27 seconds. Go ahead and do exercise 8, please. So again, it's a trinomial. There's a 1 in front of the squared term. So I'm just going to unfoil this like we did a bunch of times last class. And so y squared is y times y. This time my signs are going to be the same. And this time they're both going to be positive. And the 2 factors of 49 that add up to 14 are 7 times 7. So I see that, oh, great, I've discerned that I have a perfect square. So that's just going to be y plus 7 squared. Questions so far? I am going to add a little detail to this. So what happens when I have a number in front of the square? Now, let me just tell you, again, there's no need to know anything new or different. You could still do the AC or the grouping method here, and you could multiply the 4 times the 25 and do exactly what we did in class last time. That will always work, okay, 100% of the time. But sometimes on these perfect square trinomials, the numbers kind of get big. So I'm going to show you the shortcut. And if you want to do the shortcut, that's up to you. Okay, this is optional. It's not a required step. But here's the shortcut to discern if you have a perfect square trinomial or if you have something that needs to be factored the other way. Looking at this, okay, I've got my trinomial, and what puts my radar up is I've got a 4 and a 25. Those are both perfect squares. So I want to see, is this a perfect square trinomial, yes or no? Well, let's see. 4 is what times what? Okay, I'm just going to write a little 2 times 2 up here because I'm just checking. So what I'm doing is I'm checking to see if it's a perfect square. And then 25 is 5 times 5. So here's the check to see if it's a perfect square. I'm going to take the 2 and I'm going to take the 5. What's 2 times 5? 10. If the number in the middle is double what we just got, it's a perfect square. If the number in the middle is not double, then you've got to go and do the other method. No choice. Okay. 2 times 5 is 10. Is the number in the middle double that? Yes. Okay. So this is double 2 times 5. Okay. So it's a perfect square. When you notice that, that's good news. We can rejoice. Okay. So here we go. My first is 4x squared, so that's 2x times 2x. My signs have to be the same. This tells me they're both negative, so I'm going to put a minus. And then 25 is 5 times 5, and there we go. 2x minus 5 squared is that factor. If you like that, great. If you don't like that, then you can just do the AC method. I try to keep the numbers reasonable on the test. I'm not here to torture you. I'm just here to teach you to factor. That's what I'm trying to do. So in that vein, if you want to practice doing this little shortcut, exercise 9 is a great opportunity to do that. Verify that that is a perfect square, and if it is, which I'm hoping it is when I made the problem, if it is, then go ahead and factor it. All right, so for this one, 16 is 4 times 4. 49 is 7 times 7. So again, I'm verifying to see if I can use the shortcut or not. So if it meets this pattern, you can. If it doesn't, then you would have to do the grouping method, no choice. And so 4 times 7, what's 4 times 7? 28. Is that half, or can I double that and get 56? Yes, so this meets the structure. So here we go. It's a perfect square trinomial. So 16x squared is 4x times 4x. My signs are the same. They both have to be negative. And then 49 is 7 times 7. And there we go. There's my factored expression. Exercise 10. If you got a question, ask it. If you need me, wave your hand. I'll run to you. I'll help you out any way I can. All right, so 9 on my firsts is 3 times 3. 100 is 10 times 10. So then 3 times 10 gives me 30. If I double that, do I get the number in the middle? Yep, so again, perfect square trinomial. So that's good news. It means I can do my shortcut here. And so what I've got is 9y squared is 3y times 3y. This tells me the signs are the same, which is good. If it's going to be the same factor times itself, this tells me they're both going to be positive. And then 100 is 10 times 10. One more problem. And if you have any questions, let me know. So on this problem, 25 is 5 times 5, 16 is 4 times 4, 5 times 4 is 20. And again, we see when I double 20, I do get the number in the middle. So great. I didn't have any typos. That's a victory for me. So 25a squared is 5a times 5a. This tells me the signs have to be the same. Now they add up to a positive, so they're both positive. And then 16 is 4 times 4. And again, you can always FOIL back to make sure that you're doing this right. Multiplying is the reverse of factoring. So again, when you take this test next week, I guess it's a week from today, when you take this test, you should leave here knowing that you get all the problems right. Okay, because you can always FOIL backwards and make sure that they're good. So I'm hoping to see lots of hundreds and 95s on this next test. All right, last thing I have for the special factoring. So we talked about differences of squares. And I got asked this question, and I was very emphatic that you cannot factor a sum of squares. Okay, only differences. Okay, and then we did our trinomial squares. The last thing is when I have the particular instance of perfect cubes, I can factor both a sum and a difference. Now, just in case you're not familiar with the term, if a square is the same number times itself twice, a cube is the same number times itself how many times? 3 times, thrice. Yes, let's go old school English. Perfect. All right, so here we go. I'm just going to, now, again, I don't know how you've been taught this in the past. I'm not a big fan of formulas when we can avoid them. You can do the sum and the difference in the same general format, which is what I'm going to try to show you here. So let me know if I'm not clear. And you can see we got plenty of examples because I want to be able to make sure that we leave here all doing this perfectly. Okay, so here's x cubed plus 27. It is a sum of cubes, so I am going to factor this. Now, here's the thing. When you factor a sum or a difference of cubes, you are always going to get 2 factors. Every time. The first factor is going to have 2 terms. And the second factor is going to have 3 terms. Every time. So I'm going to start with the first factor that has 2 terms. This, I think, is the pretty straightforward factor. What you're going to do to get each of those terms is you're going to tell me what is the value that's being multiplied times itself 3 times. And we're going to write it down. So x cubed, what's the value that's being multiplied by itself 3 times? X. Positive 27. Now the sign's important. Positive 27. What's the value being multiplied 3 times? Positive 3. Positive times positive will give me a positive 27. So just as a little note here, beneath the 2 terms, I'm just going to write a little asterisk and say that each term is just the cube root. Okay, so each term is what's called the cube root. And that's just what you did. It's the number or the value that we multiplied 3 times. Everybody tracking with me so far? Okay. Now the 3-term factor, I'm gonna go out of order. I'm gonna do the firsts and I'm gonna do the lasts, and then I'll talk about the middle. So here's the thing. This is how I do it every time, even to this day, as many of these as I've done. Here's the question I ask myself. What first term here times the first term here is going to give me the first term here. So what times x gives me x cubed? X squared. I'm just going to put a little f above that for firsts. And maybe for your notes, you write out the word firsts. I'm just trying not to make too big of a mess here. I'm going to skip the middle. I'm going to the lasts. I'm going to ask myself the same question. What last term here times my last term here gives me the last term here? So meaning what times 3 gives me 27? Okay, positive 9. So whether it's a sum or a difference, you always do the exact same thing. And now here is how you get the middle. And what I need is I need a middle term that if I were to multiply everything back together, it would make all the middle junk cancel out. Because notice x cubed plus 27, there's no middle junk there. Okay, so here's how you get that. I'm just going to be straightforward and tell you how you do that. What you do is you take each of these values, the x and the plus 3. What do I get when I multiply x times positive 3? You get 3x. So I've made a big mess, even though I didn't mean to. So you multiply these two things together. So how can I notate that without making too big of a mess? I don't know. So arrows. Okay, so that's 3x. And then what you do is you change the sign. So every time you multiply these two terms in the two-term factor together, so x times 3 is 3x, and then you change the sign, you just throw that down in the middle, and it's negative 3x. And there you go. You factored your sum of cubes, and it's exactly the same thing for a difference. And I'll leave it to you. If you want, if you have some time while between problems here, multiply those two things together and verify that all the middle stuff cancels out. And that'll also help you learn to do it. If we have time at the end, we'll multiply one of them out and verify for ourselves. But in the meantime, follow that same pattern. The pattern is the same for every one of these now. Do the same thing for exercise 12, a cubed plus 8. All right, well, let's check. If you're not quite done, I understand, but I don't want to leave anybody hanging too long and struggling because we've only done one of these. So it's a sum of cubes. So I'm going to have a 2-term factor and a 3-term factor. Okay. So what value times itself 3 times gives me a cubed? A. What value times itself 3 times gives me positive 8? Okay, positive 2. Great. What is my first going to be? What times a gives me a cubed? Okay. I know that these maybe are very obvious questions on this one because the numbers and values are very small. I'm just trying to get you in the habit of asking those questions because it's the same on this problem and the exercise 15 with bigger numbers. Okay, same questions. I'm going to my lasts. What here times 2 gives me 8? Okay, plus 4. And now my middle, I'm going to take these two things. A times 2 gives me 2a, and then I'm going to change the sign to minus 2a and put that right here, minus 2a, and we're done. If you got a question, ask it. In the meantime, go to exercise 13. I've changed the sign. Now it's a difference. Okay, so that changes a couple of the signs, but the process is exactly the same. All right, let's try this out. And if you didn't quite know what to do with the negative this time, that's okay. The next couple have negatives, so you're going to get your chance to sort all this out. Okay, so again, it's a difference of cubes. Both of these things are a perfect cube. So I've got a 2-term factor and I've got a 3-term factor. So then the value times itself 3 times, that gives me y cubed is y. Now here's the big question. What value times itself 3 times gives me negative 64? Not negative 8, that would be 4, and then it's got to be a negative as well. So negative 4 times negative 4 times negative 4 will give me a negative 64. Because when I multiply the first two, what's negative 4 times negative 4? That gives me what? Positive 16 times the third negative 4 gives me negative 64. Okay, so that's why the sign is important. If you didn't catch on to that, again, it's okay. We're going to do another one in just a second. So you're going to get your chance to make up for it. So this is y minus 4 now. And then the same questions for the second one. What's my first? What times y gives me y cubed? Well, y squared. What times negative 4 gives me negative 64? We'll do the middle in a second. I'm doing the last. What times negative 4 gives me negative 64? Okay, it's not going to be a negative 16 because a negative times a negative would give me a positive 64. So it has to be a positive 16. And then, yes, what's in the middle? Well, I'm going to multiply these two things. Y times negative 4 is negative 4y. And then I change the sign, so it becomes a plus 4y. So I put a plus 4y here in the middle. Should have left myself a little more room. Sorry about that. There we go. Same pattern every time. So correct any mistakes you make. Exercise 14, that's why I put another one right after, is because I figured that negative was going to cause a little consternation. So let's fix those issues. All right, so this one's a difference again. So let's see how we do with the signs this time. So I've got w cubed minus 1. So the value that I multiply 3 times to get w cubed is w. What's the value I multiply 3 times to get negative 1? Negative 1. We need the negative. Okay, because negative 1 times negative 1 times negative 1 is going to give me negative 1. All right, so my first, what times w is w cubed? That's going to be w squared. My last, what times negative 1 is negative 1? Well, that's going to be a positive 1. And then I multiply both of these two things together. So w times negative 1 is negative 1w, or just negative w, and then change the sign. So it becomes a plus w, and there we go. Before we move on to the next problem, a question students sometimes ask is, hey, Perkster, can these trinomials here, should I be factoring them? Can I factor those anymore? And the answer is no. When you factor a sum or a difference of cubes, these trinomials are not factorable. Okay, so there's nothing else that you need to do. You can leave the trinomial on these problems just the way it is. All right, exercise 15. For the first time, I've put a coefficient in front of that initial cubed term. So do your best on this. And again, if you don't quite get it the first time, there's going to be another one right after it. All right, so let's see how you did. Ask me any questions you need to along the way so that we can leave here feeling confident and happy about factoring these things. So I'm going to have a 2-term factor and a 3-term factor. So help me out. What times itself 3 times is going to give me 8x cubed? Okay, 2x, great. And then what times itself 3 times is going to give me negative 125? Okay, negative 5, fantastic. And so my firsts, what times 2x is 8x cubed? That's going to be 4x squared. You can also think about that as division if that works better for you. 8x cubed divided by 2x gives me 4x squared. You're just doing the reverse process. And then my lasts, what times negative 5 is negative 125? Okay, that's plus 25. Again, if division works better for you, your lasts, negative 125 divided by negative 5, your calculator tells you that's 25. So there you go. And then last but not least, I multiply these two things together. So 2x times negative 5. What is 2x times negative 5? That's negative 10x. And then I change the sign to a positive 10x, and I throw that in the middle. There we go. Done. Go ahead and do exercise 16 right next door. All right, so once again, we're going to have 2 factors, a 2-term polynomial and a 3-term polynomial. So for the 2-term, I just take the cube root of each of these. So what value times itself 3 times gives me 27x cubed? And that is, yep, 3x indeed. And then what value times itself 3 times gives me plus y cubed? I think we would all say plus y. Is anyone having trouble determining these first 2 factors, this binomial? Okay, so whether you use multiplication of your first or division, however it's working for you, what do I put here? That times 3x gives me 27x cubed, and that is what? 9x squared. Excellent work, love it. And then my lasts, what here times y gives me y cubed, and that's a positive y squared. And then I take these 2 things, multiply them together. So 3x times y is 3xy, and then change the sign. So it's negative 3xy. All right, just a few more. You're doing good. I appreciate your endurance. This tends to be one of the things that hangs students up more than other things in this chapter. So I want to do a few extra problems than I normally do because I save a lot of time by giving you the worksheets. So we got these 4 more just to hit all the bases. So exercise 17, I put this on here because I want to make sure that you can figure out what value times itself 3 times gives you a to the 6. So give it a try. And we'll compare notes. All right, so what do you think? What value times itself 3 times gives me a to the 6th? A squared times a squared times a squared. Remember, when we multiply our bases, what do we do with the exponents? We add them. Yes, 2 plus 2 plus 2 is 6. So indeed, this is going to be a squared. And then you might need your calculator for this. Don't be afraid to use your calculator. That's why you get to use them. What times itself 3 times is 343? 7. Yeah, I kind of get limited in the number of cubes because they get big fast, as you can see. And so then what times what times a squared gives me a to the 6th? That's going to be a to the 4th, indeed. And then what times 7 is 343? 49. That might be an instance where using division might be a good thing. 343 divided by 7 is 49. And then I multiply these two things together. A squared times 7 is 7a squared. And then change the sign to minus 7a squared. You got a question, ask it. We've got plenty of time. I'm going to just continue going because I want to keep this as interesting as possible. Exercise 18, you're looking at the numbers. I've got a 3 and I got a 192. Neither of those is a perfect cube. So that kind of gives you a clue that what should you look for first? Yeah, take out a common factor, which is going to be, yes, a 3 in this case. So take out that 3 and then factor what's left over immediately after. So when I take 3 out, 3x cubed, when I factor out the 3, leaves me x cubed. Negative 192, when I factor out the 3, leaves negative, what's that, 64? Okay, so it's x cubed minus 64. In fact, from here, we've already done this problem. It's exercise 13 with a different letter. So don't forget, the 3 is part of the answer. It has to be included to get full credit. Okay, so please do not miss little bitty points by forgetting to write all the factors down. And then I'm going to have a 2-term and a 3-term. And so x times x times x gives me x cubed, and negative 4 times negative 4 times negative 4 gives me negative 64. X squared times x is x cubed. 16 times negative 4 is negative 64. And when I multiply these two things together, x times negative 4 is negative 4x. Change the sign, it becomes plus 4x. Again, we did that problem. If you need a little more detail, you can go up to exercise 13. 2 more problems, and then I've got one final thought for you, and then some of you need your tests from last time, so I'll pass those back. So exercise 19 is the same thing. The numbers as they stand are not perfect cubes, so you need to find a common factor first. There is one, I promise. Use your calculator. just to help anybody out, did anybody figure out what the common factor is yet? That is indeed true. Great job. So I'm going to give you another 30 seconds or so to finish the rest. And in fact, what's left is just exercise 15. So I wasn't super creative on these problems. My apologies. You deserve better. All right, so the 8m cubed, when I factor out the 7, I'm left with 8m cubed minus 125. Once again, the 7 comes down as part of the final answer. The value 3 times that gives me 8m cubed is 2m. The value 3 times that gives me negative 125 is negative 5. 8m cubed, when I divide out, when I factor out the 2m, I'm left with 4m squared. Negative 125, when I factor out the negative 5, is plus 25. I multiply these two things together. 2m times negative 5 is negative 10m. And then I change the sign to plus 10m. All right, one more problem, and then one more little bit of information. So exercise 20, last one, should be straightforward sum of cubes. All right, so once again, we're going to have a 2-term factor. We're going to have a 3-term factor. So what times itself 3 times gives me 64x cubed? Yep, 4x. Appreciate that. What times itself 3 times is going to give me 27y cubed? Indeed, 3y. So then my first something here times 4x gives me 64x cubed. That's going to be 16x squared. My last something here times 3y gives me 27y cubed. That's going to be 9y squared. Then I multiply these two things together. 4x times 3y is 12xy. Change the sign to negative 12xy. And just how I wanted to finish out, since we have time, we got like 18 minutes, you're still going to get out significantly early, is I just wanted to show you, I made this declaration up here earlier that, hey, let's multiply these two things together and change the sign, and that's going to make all the middle junk cancel out. And so I just want to show you that that indeed is true. So what we're going to do, again, because you should be able to multiply things back together to check. So I'm going to take the x plus 3 and the x squared minus 3x plus 9. I'm going to multiply them together. We're just going to verify that this works and that I do indeed get the original thing, the sum of cubes that I started with. So when I multiply this, I don't know if you at any point or if you remember multiplying longer polynomials, you just got to make sure to multiply all the pairs of things together. So I will just use some arrows to do that. So I'm going to start with the x, and I'm going to multiply the x times everything over here. So x times x squared is going to give me x cubed. Then x times negative 3x is going to give me negative 3x squared. And then x times 9 gives me plus 9x. And so I've multiplied the x times everything I possibly can. So now I'm done with it. So I'm going to move along to the 3, and I'm going to multiply the 3 times everything I possibly can. So the 3 times x squared is plus 3x squared. Oh, that looks familiar. I've got a negative right here. So those are going to cancel. And then the 3 times the negative 3x is negative 9x. Oh, again, that looks familiar. I've got a positive 9x. Those are going to cancel. And then the 3 times the 9 is a plus 27. So as promised, my x cubed. Yes, exactly. That's what I said. 27. Good job, everybody. So thank you for correcting me. I need to be humbled at least once every class. So the x cubed just comes down, but then as I mentioned, all the inside junk should cancel. The negative 3x squared, the positive 3x squared cancel. The positive 9x, the negative 9x cancel. And then I just have that plus 27. And that's exactly where we started. So indeed, that middle term does make everything cancel out in the middle.